The prisoner's dilemma is a classic game theory concept that explains how rational decision-making unfolds in real-world scenarios. A situation that appears everywhere, from international politics and business negotiations to our everyday relationships. Let's say you have a colleague who repeatedly works against your interests. If you're wondering whether you should continue cooperating with them or change your approach, the prisoner's dilemma offers valuable insights into what your best strategy might be. The premise of prisoner's dilemma stems out of a thought experiment. Suppose there are two prisoners who are being interrogated independently for their crimes. They each have two options: either to cooperate, that is to stay silent and deny the crime, or defect, where you betray your partner and put the blame on him. This leads to three unique scenarios. In scenario 1, where both prisoners cooperate, if both stay silent, they are convicted of a lesser charge and get 1 year of prison time. In scenario 2, one prisoner betrays the other. In this case, the prisoner who defects walks out free, and a prisoner who stays silent gets a higher prison sentence of 5 years. In scenario 3, both prisoners defect and put the blame on each other. In this case, both prisoners get a medium prison sentence of 3 years. From the perspective of a rational prisoner, the logical choice is to always defect. Regardless of what the other prisoner decides, defecting either reduces your sentence or protects you from the worst possible outcome. In fact, if the other prisoner's actions are equally likely, always defecting results in an expected prison sentence of 1.5 years, compared with 3 years if you always cooperate. This reinforces the common belief that people should always act in their own self-interest, even if doing so comes at the expense of others. But this will lead to prisoners betraying each other and earning 3 years of prison sentence each. Whereas if both had stayed silent and cooperated, then it would have resulted in an even lesser prison sentence. This is the prisoner's dilemma. But that was a single isolated game. Here, betraying was the most logical move. If the same set of prisoners are apprehended and interrogated again and again for other crimes, is it wise for them to betray each other? This is where the iterated prisoner's dilemma enters. In the 1970s and 80s, a political scientist named Robert Axelrod orchestrated a tournament where participants submitted computer programs with strategies to repeatedly play the prisoner's dilemma against every other strategy. Every strategy follows a distinct set of rules that dictates when it cooperates and when it defects. Let's put these strategies to the test using the simulator and discover how the iterated prisoner's dilemma produced some of the most surprising and influential results in behavioral science. For the tournament, Axelrod replaced prison sentences with a simple points system that preserved the same incentives as the classical prisoner's dilemma. Every strategy competed against every other strategy, earning points based on the outcome of each interaction. The strategy with the highest total score emerged as the winner. In this simulator, you can recreate the tournament by selecting up to 10 strategies and watching them compete against one another. On the left, you'll find a library of 17 different strategies. Browse through them to understand the logic behind each one. Every strategy is broadly classified as either nice or nasty. Nice strategies tend to cooperate first and only retaliate when necessary, while nasty strategies are generally more inclined to defect. Each strategy is also rated on 4 key characteristics: how nice it is, how readily it retaliates, how forgiving it is after being betrayed, and how easy its behavior is to understand. Take tit for tat, for example. It always begins by cooperating. After that, it simply mirrors its opponent's previous move. Overall, it's considered a nice strategy because it cooperates by default, retaliates immediately when betrayed, forgives quickly, and follows a simple, transparent rule. You can explore the remaining strategies in the same way and compare how each one behaves. To see them in action, use the live preview. Select any 2 strategies, choose the number of rounds, and watch their decisions unfold turn by turn. For example, let's compare coin flip and double retaliation. Coin flip has no fixed pattern. It randomly chooses between cooperation and defection in every round. Double retaliation, on the other hand, cooperates until it is betrayed and then it defects for the next 2 rounds before forgiving. Double retaliation is a stricter version of tit for tat. In this matchup, double retaliation won over coin flip. Similarly, we are going to see all the selected 10 strategies fight against each other in the tournament. In the tournament mode, let's start with 5 rounds. After 5 rounds, notice that most of the top-performing strategies are highlighted in red. These are the nasty strategies. In short tournaments, aggressive strategies often have the upper hand because there isn't enough time for cooperative strategies to recover from early betrayals. Let's increase the tournament to 10 rounds. The rankings remain largely unchanged, with only a slight shuffle. One nasty strategy drops by a single position. Now let's extend the tournament to 20 rounds. This is where things start to get interesting. As the number of rounds increases, more and more nice strategies begin climbing the leaderboard. By the end of round 20, 2 of the top 3 positions are occupied by nice strategies. There's another interesting observation. Many of the nasty strategies actually win more of their head-to-head matchups. Yet, despite these victories, they end up earning fewer total points across the tournament. Why? Because as the tournament progresses, the nice strategies learn which opponents can be trusted and which cannot. They continue cooperating with other cooperative strategies, allowing both sides to accumulate high scores over repeated interactions. Against nasty strategies, however, they quickly adapt by retaliating, preventing themselves from being exploited indefinitely. This is the key insight of the iterated prisoner's dilemma. In repeated interactions, sustained cooperation often outperforms short-term aggression. In this simulator, if you want to deep dive and explore how each strategy is performed in their individual matches, you can observe that too by switching to the Match Highlights tab. Just click on the highlight button, and you can observe the individual matches too. This makes it easy to understand not just who won the tournament, but why they won. If you enjoyed this video and want to explore more concepts through interactive simulations, visit xplarify.com. Discover a growing collection of educational simulators designed to make learning intuitive, visual, and engaging.